So this is 1.7e, should be the last lecture for 1.7 in college algebra. We're on page 158, talking about horizontal stretching and shrinking. And we'll bounce around and go back to the vertical stretching and shrinking too. But if you notice in the middle of page 158 in the blue box there, it says the graph of y equals f of cx. Okay, what that c represents here is we're going to put a number there in front of the x. So what we're looking at is f of, say, 2x. So what we did is we multiplied a number by that x, or we might have something like 1/2 x, and we're going to see what happens to it there. So in that blue box there, it says that if my c is greater than 1, like it is right here, it's going to shrink horizontally, and if that number is between 0 and 1, it's going to stretch horizontally. And I'll show you what that is here in just a minute. And if that c is less than 0, so if that c that goes right there, where like say a -2, it's reflected across the y-axis. So it's not only going to shrink horizontally, but because that negative, it's going to reflect across the y-axis there. Okay, so let's look at example 6 and see what we can learn from all of this stuff. And the picture there on the left-hand side of the book is the same as I have up here at the top of the page, and it's the function y equals f of x. So what we're doing in A is we're going to do a little tweaking to that. We're going to do g of x equals 2 times f of x. Now if you remember from back on page 157, we did vertical stretching and shrinking, and that had to do with if there was a number there in front of the f of x. And on page 157 in the blue box, they called this a. So there is a number in front of the f of x. If that number is greater than 1, it says we're going to stretch vertically. And this down here is what we have here. So notice what happened. We have a 2 in front of the f of x, so it's taking this graph, putting a 2 there, like right there, and look what happens to it. Instead of it only going up to -2, like it does here, it goes up to -2, 4, so it goes up. So we've got a vertical stretching here, and instead of just going to 2, -4, it's going to 2, -8. So notice what happened to the y value. They were multiplied by 2. And remember, f of x is a y value multiplied by 2, and that gives you a y value clear up here. My x value of -2 didn't change, it was just the y value. My x value did not change, just the y value. Okay, so that is the A part of that, and everything else looks good. Alright, so let's get this out of here, if I can. Alright, so let's look at the B part of it. So we're going to get rid of this, and we'll put in here h of x equals 1/2 f of x. So again, if you were to look at the page 157 and see what happens when you put a number like 1/2 in front of the f of x, let's open this up here, and we have this graph right here is an example. And so what we do is it says that when you take a number that's between 0 and 1, we shrink vertically. So instead of stretching vertically, we shrunk by 1/2. So we take our 2, our y value, because that's our vertical, we take our y value of 2, not the -2, but the 2, and take half of it. And that gives us a 1. So that means now we're only going up 1. Over here, we're at -4, we take half of it, we only go down -2 now. So for this particular function, by taking 1/2 of the function, this point, and this point all stay the same. What happened is this point and this point were compressed or shrunk or squished, whatever way you want to use it. this much, that multiple of 1/2. So it's half the depth now that it was up here. Okay, so that's B. So let's get this one out of the way. Whoops, no, we need that one because we need the bottom graph for this next one here. So let's get rid of that and put in our C. So we have R of x equals f of 2x. Okay, so because that 2 is in here, then we're going to use the horizontal stretching and shrinking. And because that 2 is greater than 1, we've got a shrinking horizontally. So notice what happened when it shrunk. The distance between here and here changed. See, up here it was 0 to 4. Here it was 0 to 2. Okay, so it shrunk by, well, basically 1/2. So what you do then is you just take, let's say that this point, the value of 2. So again, I had to pause there for a minute, but we divide by 2, that right there, in order to get our 1 here. So we went from 2 to 1 and went from -2 to -1. So that's what this 2 in here does, is it tells you that we're going to divide by this number. Okay, so what it did is it gave us a horizontal shrinking. Okay, so the next one, let's say for instance for part D, we have f of x equals f of 1/2 x, and let's see what happens here. Alright, so we're going to compare up here. Now notice, this is shrunk by 1/2. So now instead of dividing by 2 like we did up here, we're going to divide by 1/2, which is the same as multiplying by the inverse or multiplying by 2. So notice what happened here. Our -2 multiplied by 2 gives us a -4. Our -5 gave us -10. 0 stayed the same. The 4 multiplied by 2 gave us, or 2 gave us 4, and this 4 here gave us 8. So this was a horizontal stretching. It stretched out this way and stretched out this way. Okay, so that's what happens when you have f to the 1/2 power, or a number in there that is between 0 and 1. So now on this bottom one here, let me shrink this down, and in fact I'm going to move this one over. That's our original one. I'm going to move this up so it's out of the way. Get these down. Okay, so we're comparing this one here with this one over here. Okay, so notice what happened. Up here it's saying that the f is not only 1/2 like it was here, and it's going to be a stretching horizontally, but it's got a negative in front of there. So remember what I said, when there's a negative in front of there, is it is going to reflect across the y-axis. So what I did is this part here reflected, now it's over here, and this part here is now over here. And it's still the 1/2. This doubled, this doubled, this doubled, and this doubled. The height didn't double, just the width, because it's a stretching, because the 1/2 is between 0 and 1. So if the number here is between 0 and 1, it stretches. If it's greater than 1, it shrinks. Okay? So the last part of this video is taking example 7 on page 160. And what we've got is we have the general form of our equation. We have the y equals f of x. And what I have over here is a whole bunch of stuff I'm doing to f of x, and we'll see what happens here. Okay, so first thing we're going to do, as far as the solution goes for example 7 on page 160, is we're going to look at, and it doesn't really matter what you look at first, but I'm just going to look at this -3 right here first, and I'm going to do what it says, what that -3 says. That -3, according to 161, horizontal translation says that if this number here is subtracted, we're going to shift to the right that many units. So I'm going to move this whole graph to the right 3 units. So I'm going to be at here, and this is going to go up here, and here, and it's going to shift over like this. Okay, so we shifted it over 3. So that part is done. Now we're going to look at the 2 right here. And it says that we are going to stretch it vertically by 2. So what we're going to do is we're going to multiply the y values by 2, and we're going to make a little bit of a difference here. So now let's do this in blue. This graph will go up to 4 now instead of 2, and it'll come down here to here, and it'll come down instead of at 4 like it is here, it's going to go down to 8 and then come back up. So notice this point, and this point didn't change, just the y values, because when we multiply all of our y values by 2, we could have multiplied this y value and this one by 2, but they're zeros, so it's just going to stay the same, so that's not going to move. So we went from this gray one, shifted it over 3 to the red one, and then stretched it vertically by 2 and got that blue one. Okay, the next thing it says is because of this negative sign, it's going to reflect across the x-axis. And let's see if I can get us another color here. Let's try green. So across the x-axis. So this is going to go up here now, down to here. And this one is going to go down here and then back up here. So that green one is our new graph as we flipped it across the x-axis because of this negative sign. Okay, the only thing left is our plus 1. And that plus 1, let's see if I can get another color here. Let's try yellow here, see if you can see that. We're going to shift it 1 unit up according to vertical translation. If there is a number added to this whole thing, you're going to shift it up. If it's subtracted, you're going to shift it down. And since it's a plus 1, we're going to make it shift 1 unit up. So now it's going to be 1 unit up. Every point is going to be 1 unit up. So we're going to get a graph, a final graph that looks like this. And then this is going to go up 1 more than what it is there. And it'll look like that. So what I have there in yellow is my final graph. So it started with the gray one, turned into the red one because of the minus 3, and then the 2 turned it into this blue one, stretched it double, and the negative flipped it upside down, giving me this green one, and then the yellow one was the plus 1 right here. So it shifted the whole graph, didn't change the graph at all from the green one to the yellow one, it just moved it up 1. Okay, so use that on page 161 to help you when you're actually graphing these things. So that's it for 1.7. Phew.